video is for Advanced Algebra 1, and this is for Topic 1, Section 5, solving inequalities with variables. Really, the difference is that instead of this being equal sign, it's going to be greater than sign, less than sign. When it has the line underneath it, it's greater than or equal to. Otherwise, our steps will be the same, except for one. That when we get to it. So what we would do here, we distribute this -4, get negative 12x plus 4 plus 6x greater than or equal to 16. And I would combine like terms on the left hand side. Negative 12x plus 6x, negative 6x plus 4 greater than or equal to 16. Now I'm going to subtract 4 from both sides. The x side. Negative 6x greater than or equal to 12. And divide both sides by negative 6. And here's the difference. If it's an equal sign, we divide by negative 6 and have our answer. But because this is a inequality symbol, whenever we multiply or divide by a negative, so here the inequality is greater than or equal to. We're going to flip that inequality less than 12 divided by negative 6. So on a test or quiz, I may ask you for more than one answer. One of your answers could be this statement right here. And that's what I do on most problems. On some of the other problems, I also ask you to graph the inequality on a number line. And what's not okay, what's not okay is to draw the number line, put negative 2, and shade it in with the what is okay is to draw the number line, put 0, 1, 2, 3, 4, there's negative 5, 1, 2, and now the closed circle greater, less than or equal to or equal to the circle means that the negative 2 is included. Then I want the numbers that are less than negative 2. Those left. So two parts of your answer. One part is just the inequality. The other part is graphing it on. All right, number 2. Again, I would need to distribute first. So remember, it's distributive property multiplication with respect to addition or subtraction. So when we distribute this, we're multiplying, distributing that multiplication. Negative 6x minus 6 is less than 10. Add 6 to both sides, get negative 6x is less than 16. And I would divide by negative 6. And whenever I multiply or divide by a negative, I flip that inequality so greater than. And then this reduces to negative 8/3, negative 2 and 2/3. And I do need to know the improper fraction there to graph it on my down to 0 over here, and 4, negative 5, negative 2 and 2/3 here. The line there is very small, and this is going to be an open circle, not including negative 2 and 2/3. So the numbers that are greater than are right above that. Okay. you notice, I like to keep my variable left, number on the right. And so doing, the arrow of my graph is the arrow quality. And that's the true. And that's only true if you have the variable on the left. This is written as thirds is less than x, which would be the flip of that inequality. Obviously, the arrows are going to match. Okay. So moving on here to 3. I'm going to distribute. Have 8 minus 4x. I'll subtract 8 from both sides. 4x is greater than negative 7 by negative 4. X divided by negatives, flip that inequality, is less than 7/4. And to our number line, 0 here, 2, 3. That's 1 3/4. 1 3/4 go approximately here, and that's going to be open circle. And I want less than that. I want and it looks like they want us to have some fun with decimals. So notice that I have x on both sides of the inequality. So what I want to do here is I like to get those together first. Subtract 5x from both sides. I get 2x plus 19 is greater than or equal to 7. And to get x by itself, I subtract the 19 for both sides. Notice also that I chose my x on the left. For that same reason, if my x is on the left side of the inequality, then it's easier to see where the graph is. So this is going to leave us with 2x greater than or equal to negative 26. Divide both sides by 2. The inequality is going to stay the same by positive, and I get right a fraction. Y without equal. So again, what I won't accept is a graph that looks like this. Okay, or you just put one thing on there. But I will accept a graph that looks like there's negative 10, there's negative 15 this way. So 1, 2, 3, there's negative 13, and I want that to be a closed circle because it's greater than or equal to, and I want that to be greater than negative 14. Okay. So some people will look at this next example and say, well, we need to subtract 2x. And I look at this example and say, I need to subtract 2x. Because for that reason that I like to keep my variables on the left-hand side. So we subtract 5x from both sides. Negative 3x minus 5 is less than negative 22. Now I'm going to add 5 to both sides. 5. And I get 3x less than 17. Then divide by negative 3. I get that x is greater than 17 thirds, which is 5 2/3. So number line like this, and actually put this here quite a ways, or 5, 6, 1, 5, 2/3. Open greater than, then I want the then I guess I should have really started further this way, so I had a little bit more room for the arrow to show where my answer is. This would be well, it looks like I need to distribute. Do that. So we get negative 6x plus 16 is greater than negative 6x plus 9. Might see a problem here. Not a problem with it. When I go to put my x's together, they drop out. 16 is greater than 9. Remember the 3 things that happen when we solve an equation, which is an equal sign. The same 3 things happen. We get, first thing is we get a nice solution, or what we think is a nice solution. The second thing that can happen is we get a true statement. The third thing that can happen is we get a false statement. And of course, if the first thing happens and we get a nice solution, the previous 5 examples, then all is well with the world and we go on about our business. But if our variables drop out and we get a true statement, the actual answer is all the real numbers. And we can graph that. The way we graph all real numbers, we make our little graph. Then if we get a false statement, then there is the way we graph that is generally if we get one of these 2, I don't care, but I think you'll have some homework to ask you just so that they know you're understanding that here any number in this number line works, so we show it like this, and no number on this one. Okay. I'm gonna work through these, but I'm not gonna work through these examples. Here I'm gonna distribute 4x minus 5 plus 4x minus 6. Subtract 4x on both sides. -5 plus negative 6. If we knew this was going to happen, right? We had to have an example where we get a false statement. Be careful. For negative. Negative 5 is not less than negative 6. It's bigger than. And so we've got a false statement here. So we say that our answer is solution. And we graph that. Graph empty. But no graph or button. Alright, we have another incident like that here. 8x 4 plus the 8x plus 4. Add 8x to both sides. 4 plus 4. That's a false statement. 4 is not less than 4. 4 is equal to 4. If this had been a less than equal to symbol, we would have an answer. Answer would be 4. But it's strictly less than. Or if it were strictly greater than, we would have this. same situation. Use it as the false statement. Okay. See what's going to happen. Negative 6x minus 5, and negative 6x minus 3. 6x, 6x, get negative 5 is negative 3. That is a true statement. Negative 5 is less than negative 3. The answer here is all real numbers. Or I would make two parallel lines and change the first parallel. So we'll have some work